All right. Hello, everybody. I'm Kyle. I'm the team captain of Glitch on BattleBots, and also I was on part in my high school years. Made the two bots in the back there on the left side. Let's get started. Okay, so first thing as a disclaimer is that combat robots are very dangerous. The scale that people use is comparing it the kinetic energy that the weapons store basically to guns. Is that normal bot will have like twice as many kinetic energy as a handgun. So if you touch it, it will harm you. And so everything you do should be avoiding all possible way of the weapon being near you or others when you're testing, when you're competing, and even when the robot's driving around, making sure you don't hit yourself on sharp points, because people like to make sharp wedges for scraping and that sort of thing. So read the safety protocols, please. Yeah. Okay. Let's start with a quick history lesson now. So BattleBots IQ was created 15-pound events, and then now NRL is the league that runs most of these events after BattleBots IQ kind of faded away. The Midwest has a lot of these events, but it's really just starting out on in California. So it's smaller than if you've done a VEX or FRC tournament, but still against high school and college age teams. I'm not sure exactly what the split is right now. I think it's, I don't know. And then is within the NRL rule set, which has no lipos, is a big exception to most other rule sets. And then also there's an NRL Nationals competition in May. So the arena is an octagon, which means there's no corners for you to get stuck on. There's no out of the arena zones. It's just pure robots hitting each other. It's about 12 feet wide, 10 feet tall, and completely fully enclosed. This one's a little bit uneven in certain parts, so the floors are uneven, and there's a seam between the wall and the ground, so just be careful of that, of their potential places you can get stuck. Tournament is normally double elimination bracket, and then we want to do a grudge matches to guarantee 3 fights. Right now there's about 20 teams, but more are getting interested, so the estimate is about 20 to 30, and there'll be a big rumble at the end, which is every bot that wants to goes into the arena and just fights all at the same time. And then we try to guarantee as much time for fixing as possible, but at some time there's like the schedule has to proceed. You can't wait hours and hours. So the maximum guaranteed is 20 minutes. And then if you've seen BattleBots, you know this, but the main scoring criteria is you win if you have a knockout. That's 10 seconds for no controlled movement. So if your bot cannot drive, and then if it goes for 3 minutes, which is the match time, then it goes to the judges, and these judges score based off damage, aggression, and control, with damage weight as the strongest factor. So at the 15-pound class, you're going to be seeing a lot of vertical spinners for bots, which are, I don't think you can see my mouse, which are just the vertical spinning bars and discs and drums at the front of these weapons, and then you have horizontal spinners, which are horizontal spinning bars or discs that are either over the top of the bot or sticking out in the front. And then you'll have there'll also be wedges whose goal is to control the match and to like destroy the other opponent on their wedge. And there's some lifters, some grapplers, but we don't see it too often. Okay, so now we're gonna go into some technical recommendations for the bot. Most teams use aluminum rails with bolts. This is because you can swap out frame pieces as opposed to if you have a huge welded steel frame that's one uniform body, or if you make a billet bot, which is a piece of metal that's just carved into one chunk. If it gets damaged, you can't really replace it that easily. So most teams stick to the multiple rails and mounts, and then they either have holes and tap, which is create threads in the rails, or they have net strips are a pretty quick, easy option to add those bolts. Yeah, and then in this technical section, there's going to be a lot of small info on the slides that I'm not going to read all of it, but please use it for reference even after this call, or if you need any help with actual specifications. Oh, big important thing is leave space for wires and connectors. That's something I've personally struggled with almost every single bot I've made. You need space for these connectors, and they will need space to curve around. It's not going to be perfectly 90-degree angles that the wires can make. They will need space a lot more than you expect. And having that space is kind of critical to being able to pad those electronics properly and to actually fit things in the bot. So the drive. First thing people assume when they're new to BattleBots or combat robots are that exposed wheels are bad. They're obviously going to get taken off, but that's not necessarily the case. It's not always the case that they're better. It really depends on the bot design, but that'll mean you'll need to figure it out for yourself on what you want to do. But don't instantly rule out, oh, we need to have this small piece of metal go around it because that'll make it not break, when really that small piece of metal is going to bend into the wheel. Just be conscious that you can make exposed wheels durable and you can make wheel guards that are weak. It really just depends on where you want to prioritize your weight and the balance of your bot. Yeah. Most bots, even if they're four-wheel drive, run off of 2 motors, just using belts. And then we have some recommended gearboxes and wheels. I'd recommend BaneBot's wheels over Coulson wheels. They have a bit better traction, but Coulson wheels are also a strong choice. If you've done FRC, those should be familiar names. So the weapon is very interesting. People don't really have the exact physics of weapons figured out yet. I know Robotics, which is a big team that's lasted for 20 years. They really did studies on engagement and weapons and how to deliver as much damage to the opponent, but now they're completely changing their design since then, right? So it's not an exact science. Well, it is a very exact science, more than computers really are able to simulate, because there's so many factors in the design that are not typical. For example, you want to store as much kinetic energy as possible. The goal is to deliver as much kinetic energy as possible. To do that, you have to store rotational inertia, and you have to store RPM. So theoretically, right, if you hear that, you might think, oh, let's make the weapon go as fast as possible. Hundreds of thousands of RPM, make it infinitely going fast. But if you do that, then the opponent can never get into your weapon. Like they literally, if this is spinning and it's spinning fast, they will not be able to go in. So there's a balance there of, to deliver that energy is completely different from storing the energy. And so you have to do a fine balance of how far do you want the opponent to go into your weapon, which is kind of called bite. Like, do you want your tip to be sharp so it digs into the opponent better, or do you want it to be blunt so it's more durable? Do you want it to be lighter so you can put weight into other things, or do you want it to be a big, heavy weapon that can, like, one hit destroy the other opponent? Or do you want to have like a slower weapon with less energy so you can control it better? Because if you have a vertical spinner or a horizontal spinner, there's going to be a gyroscopic effect. So as vertical spinners, their frame like turns, it rotates, the bot will lift. If horizontals, it will pull them in a circle. So there's a lot of factors in there. I really recommend watching the video that's linked at the top. It's from someone on BiteForce, BattleBot's team. And they really explain the physics well, and how there's just so many design choices that really, there is no optimal weapon. It depends on your design and the trade-offs you consider. Some tips: the center of mass, which is the point. You can do this if you use CAD simulation, or if you make a symmetrical weapon, to know where the center of mass is. So, for example, there's going to be a like center of mass for your entire bot, right? And that's going to be somewhere within your wheelbase, as an example. If it's not, it's going to tip. Imagine that for the weapon. If it's not at the center, then your weapon is going to wobble a lot. And if your weapon does that, then you are going to be vibrating your entire robot apart. I recommend watching a BattleBots video, which is Tombstone versus Rotator, for a very good example of what happens. They have these bolted steel teeth on aluminum. Tombstone has these bolted steel teeth on a big aluminum bar. One of their teeth gets knocked off, and then they completely rattle, and they're jumping around the entire time because that center mass is no longer at the center of rotation. So you have to do that when you're designing it. Something I recommend would be to have a single tooth weapon, because then you can double your speed for the same amount of depth into your bar, as I was talking about before. But that will require some more complex design, and you'll have to make sure that with that asymmetrical design, that center mass is still at the center of rotation. So you're going to have a bar side that sticks out farther, and then a counterweight that has more mass but is shorter into the weapon, so it doesn't hit. Yeah, and then you're going to be having some bearings on there. There's some options down below, but the main thing is strongly recommend that you put your bearings on the spinning weapon, and not on the not in the frame. So what most people do is they have their weapon shaft, which is what the weapon rotates on. They have it completely fixed, bolted onto the frame. The shaft does not spin at all. And then they have a bar with bearings that spins on the shaft. So the bar spins and the shaft does not. And then they bolt a pulley to the weapon to power the motor to it, as opposed to having the shaft rotate, have the weapon fixed to the shaft, and then have the frame be the basis of like still movement. Hopefully that makes sense. Okay. Armor, forks, and wedges. So some teams do armor on their bot, some don't. And by armor, I mean something other than the frame, just wrapped around the bot to add more protection. If you don't do that, you're just going to have your basically frailed aluminum rails. They can be angled if you want, which adds some complexity, but it helps deflect force. Or if you want, if you have a steel frame bot, or if you want to add steel armor, you can add steel armor wrapped around, or UHMW, which is a plastic that has it's an amazing amount of strength. The one thing is that it can crack at significant amounts of, like, if it's cut into it. So yeah, you'll see those three things a lot as a common theme for bots. And then wedges. These are typically happen more in vertical spinners than, or vertical spinners and like solely wedge bots than basically every bot except for a horizontal spinner is gonna have a wedge. And what I mean by wedge is a plate that leads into your weapon or is your weapon, and that has to be a very hard material so it doesn't deform and get chewed up, so opponents can still slide up it. And yeah, it has to be angled so it's not just the wall that you're pushing people away with. And then forks, these are something people are really starting to use now, is hinged, spring-loaded or magnet-loaded, not necessarily that, but often that plates or like sticks out, or just prongs that stick out, that's the word. But the goal with them is to have something that's always on the floor, as opposed to a wedge that will be lifted off the floor with uneven ground, and that will slide right other opponents, or other opponents' forks if you have a better fork design. And then the goal with that is just to be the one that has your weapon hit them as to have their weapon hit you. And they can come with risks if they can get stuck on the floor, especially by that wall area, or if there's seams on the different plates. And if they get bent upwards and they aren't designed so they either break off first before they bend, or that they bend in front of the weapon as opposed to behind it, they can potentially stop people from going into your weapon, which is the opposite of their purpose. So overall background, there's a lot of considerations and trade-offs with bots, which is really why no bots are really exactly the same, because these are all potential and like good choices. It's kind of like a game of rock, paper, scissors of who does certain trade-offs will beat other bots depending on what they decide. Same with like weapon choice and armor choice and that sort of thing. So big ones are protected versus exposed wheels. If you wanna try to thwart the opponent, or if you don't want to get stuck, if you want to have a complex bot, or if you want to be able to repair it, or to be able to have enough time to repair and swap configurations. And then if you want to have configurations, but sometimes that can make the bot less durable depending on how you design it, because you're not designing it for the one peak, you're generalizing the design. And then it also has to be done in 20 minutes, but it can be better for the opponent that you're fighting against, right? You're catering your bot to beat your certain opponent, and helps reduce some of that rock, paper, scissors game, because then you're rock and scissors first. Okay. Electronics. This is not my specialty, but I'll give a brief overview. The main thing is they need to be reliable, and they need to be reliable in combat robots, which is hugely different from they need to be reliable for their intended use case. So a lot of these motors are supposed to be for drones. You aren't flying a drone, you're fighting with a bot that can get absolutely flown around, thrown to the roof, have everything bend in it, and you still want to be going. So you need to make sure that it's something that people have either done before, or you're confident and you've tested it. So really look for people's recommendations on these, whether it's on, like, there's a big Combat Robots Facebook group or Combat Robots Discord group. Get some advice or see what people have done before. Motors. So in the lower weight classes, people are now really starting to steal brushless motors. It's just the type of motor that doesn't have brushes, as opposed to a motor that does. And they have a better strength to weight ratio. That's why people use them. Power to weight ratio. And the problem is they involve a little bit more work to get going, right? Because they're drone motors. They're supposed to be going one direction. So you have to update their firmware with the people have posted firmware online, but you have to be able to update the firmware and tune some settings to be able to run the motors in this new use case. And yeah, there's two categories of them: outrunners and endrunners. It's just, does outrunners, they have a part that bolts onto a plate, and then the outside rotates like this, yeah. And then endrunners are inverse, just the inside rotates. To tell by the name. Just be careful when you're mounting the drive motors to gearboxes, because the shaft that the gearbox inputs might be different from the shaft that you have for your motor, and so you either have to output, you have to modify the gear that you're inserting the shaft into, and you might have to modify the output shaft of the motor. And then brushless motors they're a good starter option. They're cheap, and they're basically, you can plug them in and they go, because it's just direct amount of voltage basically that you're giving to them, as opposed to brushless motors have a complex like timing system with 3 different phases, and that's why they need that extra programming. Weapon motors, really, they'll have to be high performing, or else they'll kind of blow up. or multiple lower ones. And then there's some recommendations on the tri-motors. Most people do not have gearboxes for their weapon motors unless it's a lifter. If it's a spinner, they'll just do directly mount a pulley to the motor and then a pulley to the weapon. Okay. Speed controllers. So I'm going to take a step back here and give an overview of kind of the electronic system of combat robots. If you've done Vex or FRC, it's a bit dissimilar to that in that there is no central control system. You don't have, in that sort of system, you'd have your controller that you're controlling on, and then it goes to the central processor, and then you connect all the motors to that. It's a bit different. You have your controller or your transmitter, and that goes to a receiver, kind of like an RC car, and then that receiver goes to your speed controllers, which are each individually going to a motor. And people do this for durability reasons, because most processors either have to be heavy or they'll break. Yeah. So motors have these individual speed controllers. And really, you're just going to have to find a speed controller that meets the specifications of your motors. And it'll have to meet those specifications when the motor is doing the absolute maximum that it can do. So you'll see on a motor, there's like a continuous pull of amperage rating and like a burst pull of amperage rating. The speed controller has to be able to handle the burst rating. So yeah, just make sure the amperage and the voltage numbers line up for your speed controllers. Okay. So as I talked before, the RC car type receivers, they have to be powered. That's typically about 5 volts, and what most people do is power it off of the speed controller, one of the speed controllers. So you're gonna, most teams have this one battery, maybe like 12 volts, 24 volts, and that goes into the speed controllers, and then that speed controllers has a small 5-volt output that can go into the receiver. And if you give that 12 volts or 20-volt bursts directly from the battery to the receiver, it will blow up. So you either need to go off the speed controller or a separate smaller battery. And at this weight class, most people just do the speed controller. It's really important that you set up a fail-safe on the receiver. So that means when you lose a connection, that's the speed that it will tell the motor to go, right? So if you have your weapon and you're going at your max speed, and then all of a sudden like one of your wires for your receiver, this has happened to me several times, gets completely blown up. There's 2 things that could happen. One, if you don't set the failsafe, you could have your weapon constantly going while you cannot control your bot, which is not ideal. You will have to have someone push you in, like another bot push you into the wall basically repeatedly to basically stop your weapon from going, or to make your battery die, which is expensive. You don't want to do that. Or you could set the failsafe, which means if it loses connection, it will make the motor stop. Please do that. And then it'll also be a requirement at the competition that you have your failsafe set up. It's just, please do it when you're testing things too. Batteries, again, it's the national, the NRL rules, no lipos. Lipos are the best performing batteries, but they also explode, so it's a safety thing. Several options here, and then with the connectors that people typically use. So the connectors, just when you want to connect one wire to another wire while making it removable, right? So if you completely hard mount all your wires or solder all your wires together, right? You won't be able to swap components. So in between each component, like to a speed control to the motor, we'll have one of those connectors. So safety. One, you need a safety light. You power this like the same way as basically the receiver. You want to know that if you want to know that if your bot is turned on, it is actually turned on, so you can actually start a match. And also, you want to know if you turn it off when it turns it off. Mostly the second one. It's a kind of a safety concern if you don't know whether your bot is live, but also don't rely on the safety light completely, especially during a match. If the bot gets thrown around and the light breaks, don't assume that because the light is off, the bot isn't live. You want to always still, if you don't know for sure, as in if you don't physically turn your power switch and see the light go off, assume that it's live. And then that power switch, what I talked about, is a mechanical power disconnect. So before your battery connects to all the speed controllers, you need this to block the current from going. And it's just a switch that you can basically have turn on or off the bot. Allows you to be able to put the bot in the arena and handle it without the potential of it just randomly starting in your hands, which is fantastic when you have weapons spinning at thousands of RPM. Battle hardening. So as you can see in the photo, people make modifications to their motors to make it strong. The most common case of this is with these outrunner motors. That's what people think of when they hear battle hardening for combat robots, is adding this epoxy and glass microspheres. There's a link there. So the magnets in the motor don't break. And then there's other cases there's like, if you have connectors, you want to zip tie the connectors so they stay together. Had one of the times in the match before he started doing that, it got flown to the roof, fell back on the ground, and our battery connected, snapped a plastic plug, and went open, so the bot was not powered anymore. As opposed to if you have like a thick zip tie, that's not going to happen. All these connectors, you want something to keep them together. All your electronics, you want to mount with foam, or keep them loose and pack them with foam around, except for something that's extremely durable, like a power switch. And for power switch also, you need to know where the switch is located so you can turn it on and off, not just have it loose in there. And then for mechanical fasteners, people use Loctite, which is kind of fluid that will harden after a certain amount of time. So you put this fluid on your screws, you screw it in, and then it will harden in the threads so it doesn't loosen up during the match. Similar to kind of like a nylock nut, if you use those, which is just a nut that has a plastic insert that you kind of screw into. Materials. The weapon, people use steel, which is kind of expected. When people have parts of their bot that they know are going to be impacting, they typically have harder materials and more dense materials. So the weapon, wedges, forks, all things that, you don't want to get deformed because that would be bad. Some people use impactors that they bolt onto the weapon. So a steel piece that they bolt onto like aluminum weapon body. And that works too. It's just a thing that you want to be hitting the opponent. Should be steel. People typically use S7 tool steel or AR500. AR500 being, depending on the case, easier to make or harder to make. AR500 is a lot easier to make with 2D shapes, and S7, since you have to harden it later, is easier to make if you're CNCing it. Okay, and then frame. So before, people typically use 6061 aluminum. That's that aerospace grade aluminum that has a great strength to weight ratio, and when it breaks, it deforms rather than cracking like other grades of aluminum. And that's something you really want. You don't want your bot to split in two. You want it to bend and keep on going. Armor wedges before steel. Some people use titanium. It's getting pretty expensive right now, but it does have slightly better performance. And then for that spread armor, that ultra high molecular weight plastic. And then forks, steel again, especially since they're typically lower size. If the thinner they are, the better they are at their job. That's another reason people use a more dense material. Fasteners. People use black oxide alloy steel screws. So if you ever use McMaster to buy your hardware parts, that will pretty much always be an option. I recommend that over soft ones. Okay. And then weapon shafts. If you have a spinning weapon or a lifter or something, people use shoulder bolts, which are a big bolt that is not threaded. So you have your head, and then you have no threads for a while, and then the end is threaded. And this allows you to just put your bolt through your entire frame and then have your nut. Like you have two rails, you have the head of your bolt, you have the unthreaded part that your weapon is on top of, and then you have the nut on the outside. And it really makes it very easy to replace and durable because you have a large nut on the side. And then, but some it's a bit heavier. And then some people have steel or titanium, just simple rods, and then they either put shaft collars on the outside, or they have plates that they bolt onto the side of the rails to prevent that shaft from going in and out of the butt, unless you want to do that for replacing your weapon. You can screw it. pulleys and belts. Everyone basically uses aluminum for their pulleys, and at this weight class, you really want to be using timing belts. And notice especially how there's no chain here. Chain is really heavy at this weight class. Timing belts, which are basically the belt version of chain, they're strong enough and they're a lot lighter. The other option for belts, which are not timing belts, are V belts, which are in a V-ish shape as their belt profile, as opposed to teeth. And they rely on friction to spin the weapon, and you'll need a tensioner system. And really for the point of it is so they'll slip if you hit the other opponent and don't transfer energy into your motors. But I've ran timing belts, which put that power back into the motor for every single bot. And at this weight class, my motors have never broken. Yeah. At larger weight classes, I just turn V belts because they're weaker for that weight. Internal mounts, the UHMW are people 3D print in onyx or carbon fiber nylon or whatever. If it's not as important to be durable, if it's just a small mount for like electronics for organization purposes, you can also do some simple PLA or ABS filament. Weapon safety. You should be practicing weapon safety. As I said before, please be practicing weapon safety even before you're at the event. And that involves multiple components. You need a safety pin, which if you have a spinner or a lifter or a weapon that moves at all, you need something that stops its rotation that you can just slide into the bot before or after matches. And then that will stop it. So if it accidentally gets powered on, you don't have a huge weapon spinning around that you didn't intend. And then safety colors, basically just like a pool noodle you put over sharp edges so you don't cut yourself, as I have many, many times. Fail-safe setup, as we talked before, and never ever test your weapon outside of a test box or outside the arena because it's just not safe. Things can get loose, they can hit dust on the ground, and it's just spinning with enough power that can be really dangerous. And then read more of the handling guidelines. That finishes the technical section, I guess. And there's some resources here and discounts you can see, and also the tentative schedule for the event. Yeah, that ends the slideshow. If you have any questions, please let me know.
Okay, and we can also, if you want to point out a few things or if people have questions, we can put the video camera on washing machine, which was Part's very first combat robot. Pretty straightforward build, chassis, weapon, and then RG Beater, which suffice it to say, a much more complex robot. So, but first, any questions? Either jump on with your audio or in the chat. Okay, Kyle, is there something in particular you want me to start with? You want me to start with the washing machine? video? You have to tell me how this works. Is that a good enough view?
On someone else's video? Oh, it's on the first screen share. Okay. Yeah. That's good. Yeah, that's washing machine.
You want to spotlight that?
It is for me. I don't think spotlights for everyone else. Oh, it does? Okay. I don't know Zoom. I think spotlight.
I'm spotlighted.
One second. I don't know Zoom. Yeah. Okay. So that's washing machine. It's a pretty simple box. You can see rectangular chassis. It has the brushed motors, which are the easier to use motors, and the basic electronics control system, as I was talking before. You can't see it, but in the back there would be a battery, and then there's also the receiver and the two drive speed controllers. Those drive speed controllers connect to the weapon. In that front on the left side, you see the weapon speed controller, and on the right side you see the weapon motor. And then that weapon speed controller is what goes back and powers the receiver. There's the BaneBot 16:1 gearboxes, and then there are BaneBot wheels, and there's a simple pulley ratio from the weapon motor to the weapon that slows it down a little bit. So there's that better engagement and a faster spin up time.
Yeah, so this bot has probably been through, let's see, 1, 2, 3, 4, 5 full competitions as the original design. Does that sound about right, Kyle?
Yeah.
And probably the only thing that was kind of redone between those was a new chassis walls on the outside. But the drum, Kyle was talking about, vibration. At one point, the drum, the offset teeth were on the opposite side. The drum lost a chunk of metal, and the team's kind of been chasing vibration since then and playing with different ways to kind of fix that, in the middle of competitions, throwing extra bolts in, that type of thing. You'll notice that we have this one set up for bench testing right now. So there's no belt on the weapon, right? So we can test the motors, put it on a block, test the drive, test the weapon motor without actually having, the weapon itself engaged. So, and this is the battery. There's, the common approach that we've seen is that the people custom making their own packs. They can either using lithium ion or the Life PO4. We just took simple DeWalt, right, packs. All of our teams at Part use basically DeWalt drill packs that are the case broken up and then put in the connector of choice. So. Power switch is probably the only other thing kind of buried. This is the NBOT style, which is smaller. All right, questions on this bot before we go to the next one? Okay, Kyle, you want to talk through?
So this is the remains of RGB. it got beat up at the last comp where it tried to run as a 12-pound bot. So you can see there's the smaller weapon there. Yeah. Bit of a different shape than washing machine. It has the 4-wheel drive. It used to have Omni wheels in the back, but it got modified to just be normal traction wheels. Yeah, has the same kind of the standard electronic system. It has the battery to the speed controllers to the same number of motors with a power switch there and receiver there. The difference for these ones, it uses the prop drive outrunner brushless drive motors. As you can see, they're a lot smaller and they actually output more power than the washing machine ones. Yeah. You can see the frame rails have cheesing in them, as opposed to washing machines, just straight walls. And this was using Fusion 360's shape optimization software, which is actually pretty simple to use. You can find like a 15-minute video online and it explains how to use it pretty well. You just design your outer shape, you put loads where you expect loads to be, and then it will tell you which part of the frame is like the least important to counteracting those loads. So you can estimate how much support you want to try to minimize that weight or put weight elsewhere. As you can see, the loads were not made for a horizontal spinner. And that's because, at least in the 15-pound class, I knew there weren't many people competing with heavy hitting horizontal spinners. But in the 12-pound competition, there are. So yeah, that's what happened.
Well, and without the larger weapon to defend the front end, right?
Yeah.
So Kyle, you talked about the dead shaft versus live shaft. So here's the example of the dead shaft with the bearings.
The bearings inside the weapon. That type of weapon is called a beater bar. It has the horizontal, the side profile is the shape of a bar, but it has that hollow inside and mass on the ends to increase its rotational inertia, like to more than what even a disc would be. Yeah, and this allows you to. The goal is so your weapon is exposed sticking out of the bot less often. So if you're against other opponents, you'll be more likely to be the one that your weapon hits them rather than theirs hitting you.
The team couldn't run the example, but the fork. The team couldn't run that because when they were trying to cut it weight to 12 pounds, they didn't. In addition to cutting the weapon down, they had to take out the little wedgelets. Okay, does anybody have questions? Okay, well, a couple of things, I guess, on the competition itself. We are up to about 20 teams. The vast majority of them are, I shouldn't say the vast majority. Right now, I think it's about 6 or 7 college age. The rest are high school, either directly associated with the school or independent. We're pretty close on getting all the grants finalized. We had 5 initial grants to help new teams kind of get started. I've been in touch with at least a couple of the teams. We'll get the rest of those rolled out here shortly. We can also include kind of a recommended, if you have folks who are for the new teams, if you already have controllers for drones or for other things, and you have access to those, that's great. But if you need a recommendation kind of on a low cost transmitter receiver pair, we'll have those. We can publish the motors that we've used successfully, but as Kyle said, that there's quite a few resources out there on Facebook, the Discord. The Facebook is the older builders, the ones who've been around. BattleBots and combat bots forever are out there. They're great resources. It's just Facebook's difficult to use as a search function, and it's Facebook. For the students, I think the Discord, the OTA Discord, right, Kyle, is the most common one.
The arena is what that stands for.
Okay. When we put the slides up, we'll back up in the recording. I'll put it on the web page, but that'll include the links for the discount on Send Cut Send if you need to do outsourcing, in particular for their AR500. Costs are really quite good versus having to go out and kind of buy it yourself and then deal with the machining. And Hobby King right now has a 25% off sale through December 4th. So that's something, if it's hard because you want to get your design first, but there's some pretty common things like the prop drive motors. There's a couple of other typical ones that if you want to get those and kind of build your design around those drives, that's certainly an option. So questions? Okay, well, thanks to everybody. Thank you, Kyle. We'll feel free to shoot us an email, either at the events email or my direct one if you guys have questions. We'll do some more clarity around the rules in particular, and for the new teams, if you have any questions on that. We built a test box a few years ago based on Martin Mason's recommendation. And so if, as Kyle said, you shouldn't be doing any weapon testing outside of an actual test box or on the arena. We're hopefully going to have the arena set up the Friday before and do kind of that piece of social if COVID conditions kind of allow us to do that. So that'll kind of give you a chance to do testing and figuring out, if your choices on ground game in particular. Kyle mentioned this, the floor on this arena was pretty rough at the last event that we were at. We will try and, get it bolted down pretty good, but you should assume that there's going to be seams exposed, some places to get high centered and things like that. So, as Kyle said, that our team had to basically hack off, the Omni wheels that worked pretty well at the previous time, just because I think the bot got stuck a couple of different times. So they were able to kind of improvise. The traction wheels worked much better on that floor. So. All right, I think we're good. All right, thanks everybody.